After understanding the first come first serve scheduling algorithm and shortest job first scheduling algorithm, the third one is the round robin scheduling algorithm. These algorithms are designed especially for the time sharing system. It is similar to first come first serve scheduling, but preem- preemption is added to switch between the processes. So therefore we say that it is similar to FCFS scheduling, but preemption is added to switch between the processes. A small unit is called as a time quantum, or the time slice is defined as a time quantum is generally from 10 to 100 millisecond in length. So now we will having a ready queue, right? So ready queue is treated as a circular queue. The CPU scheduler goes around the ready queue, allocating the CPU to the process for the time interval of one time quantum. Now to implement round robin scheduling, we keep the ready queue as FIFO queue of the processes. New processes are added to the tail of the ready queue, and the CPU scheduler picks the first process from the ready queue, set a timer to interrupt after one time quantum, and dispatches the process. Now, one of the two things that can happen. What are the two things? The first thing is the process may have the CPU burst less than one time quantum. The process itself will release the CPU voluntarily. The scheduler will then proceed to the next process in the ready queue. Otherwise, if the CPU burst of the currently running process is no longer than one time quantum, the timer will go off and will cause an interrupt to the OS. A context switch will be executed and the process will be put at the tail of the ready queue. Now the CPU scheduler will then select the next process in the ready queue. So these two things will happen, right? So we will go back and we will little more we will understand about this round robin. So we are saying that round robin scheduling is similar to first come first serve scheduling, but the preemption is added to the switch between the processes. It means that if you see this figure, right? So this is a circular queue, right? This is called ready queue, is treated as a circular queue. So this is the ready queue, right, which is treated as circular queue. Round robin means uh, in first come first serve scheduling basis, the all the processes will be getting one small unit of time called time quantum, right? So that time quantum may be from 10 millisecond to 100 millisecond in the length. So one time quantum will get by one process, and after completion of that time quantum, or we can say the expire after expiring the time quantum, the process need to leave that time quantum, right? So the CPU scheduler goes around the ready queue. So CPU scheduler will goes around this ready queue, allocating the CPU to the process for the time interval, right? So CPU scheduler goes around this ready queue to allocating the CPU to the processes for a time interval. Now here also if you see this queue, right, so front and rear, so every process will get one time quantum. Okay, so to implement this round robin scheduling, we again treat the ready queue as FIFO queue in processes. Whichever comes first will goes out, right? First in, first out, queue process. So new process are added to the tail of the ready queue. So tail means at the rear of the queue, the new process is added. The CPU scheduler picks the first process from the ready queue. So whichever at the first in the ready queue, so it will be picked by the CPU scheduler and set the timer to interrupt after one time quantum. So it will give you one time quantum to that selected process, and it doesn't disturb in between, right? So it will interrupt after one time quantum means whatever the time is allocated, in that time allocation, the process has to complete its CPU burst time. So if the CPU burst time doesn't complete in a given time frame, right, so it is interrupted after one time quantum, and after execution of all the processes in round robin fashion, right, so in circular fashion, so again that process will get the next time quantum, right? So it will dispatch the process, means this CPU scheduler picks the first process from the ready queue and gives the timer or the time slice to that process, and only interrupt after that one time quantum and dispatches the process. Now we are saying that one of the two things that can happen is whenever the process may have the CPU bus less than one time quantum, the process itself will release the CPU voluntarily. So assume that the time which is allocated 10 milliseconds. So 10 millisecond is the time quantum. Let us say example 10 millisecond, right? So process is executing, but process need only 5 millisecond, right? So the process may have CPU bus less than one time quantum. Less than one time quantum means a time quantum size is 10 millisecond. CPU bus time required by the process is 5 millisecond. Then the process itself will release the CPU voluntarily. It doesn't hold for 10 millisecond. It will release right after 5 millisecond. The scheduler will then proceed to the next process in the ready queue. So the scheduler can select the next process. A scheduler will not wait to expire this 10 millisecond. It will goes to next process in the ready queue and select the next process for the next time quantum. So this thing can happen. The other thing is, if the CPU burst of the currently running process is longer than the one time quantum. Continuing with the same example, we have a 10 millisecond time quantum, right? 10 millisecond time quantum. Assume that our process need 20 millisecond. So P1 need 20 millisecond, right? Mn 20 millisecond. Now it can occupy this time quantum and complete its 10 millisecond execution, but it doesn't complete its CPU burst, right? So CPU burst of the currently running process is longer than one time quantum. So time quantum is 10 millisecond, and the process CPU burst time is longer than this time quantum, that is 20 millisecond, right? Then the timer will go off after 10 millisecond. The timer will go off, right, and will cause an interrupt to the OS, means this process will get stopped after completion of one time quantum. The second and next time quantum is allocated to the next processes, say P2, P3, right? and in circular fashion after completion of all the processes. Again in circular fashion, the P1 will get one more time quantum. So here a context switch will be executed and the process will be put at the tail of the ready queue. Again this P1 will be put at the tail of the ready queue. The CPU scheduler will then select the next process in the ready queue. So after expiry of this 10 millisecond of the P1, the scheduler, right, CPU scheduler will select the next process in the ready queue. So in this fashion, this round robin will work. And among these two things, one can happen, right? One can happen. So when we implement this round robin scheduling algorithm, we will understand both these 2 points. So right now just remember these two things, and we will come up with some of the examples where we can understand all these two things in those examples. So this is all about the round robin scheduling algorithm. This is just the introduction of the round robin scheduling algorithm. In the next lecture, we will understand the round robin scheduling implementation. So thank you for watching. See you in next lecture.